of completion, you have a pure B, and that's their Gibbs energy differences. And then if I just having at different composition, without think about the mixing contribution, just say, I have a $2 in the checking account, I have a $5 in my savings account. How much do I have, and what's the ratio? And if I can keep on changing it, I guess I have a different amount of the Gibbs free energy contributing from each one of them. Just simply count how much you have contributed in each way. This is what I call without considering the mixing. What you essentially see it is you have two banks, right? A and B, and I don't worry about it. I'm just one thing is this is A, this is B, this is A, and this is B. I'm just looking at how much do you have in each one, and then what is the total summation of the G, and this line represent those without considering the mixing. But now, and this was actually when I was a student, that I think that maybe this is good enough, right? If A goes to B, B goes back to A, but I think the B has a lower Gibbs free energy than A. So if you have a rolled ball, you gotta go, right? And that's why you have a spontaneous reaction converting A to B, and you are expected to happen at 100% conversion, because that has a lower energy, right? It's just like this, right? High energy, low energy, high energy stuff converting to low energy by the reaction. And we all know that conversion to 100% is not possible. And this is because this mixing only, because of the mixing term, that is also contributing. And if you're looking at the mixing, you already remember delta G mix was having a form looks like this. Okay? So this has we talked about it before. So if you combine this, you will have something looks like that. This is what you have. So although there is a Gibbs free energy, the difference is this one essentially destined to have a little curving down, and because of that, this position is at the minimum. It is somewhere in between. You will have an equilibrium composition where your delta GR is essentially is a zero. So which is the slope here is a zero, which is the minimum. So this is a concept that you want to know, whether this one is much lower Gibbs free energy, but there is something that by going the other way, which is producing higher Gibbs free energy reactant, you have something to gain. You are essentially creating more entropy to the system, and there is a little kickback for the system to have. So this is one of the conceptual pieces that it's not possible to have theoretically 100% conversion A to B. And because of the mixing is always favor the backward reaction. They don't prefer the pure form of one over the other. Okay.